Everybody, welcome to the August Research Interest Group meeting for North America. I'm very happy to have you with us here today. This is an exciting Research Interest Group meeting because this is the chance when we get to brag about our summer interns. So we have 4 summer interns who have completed some very interesting projects this past 3 months, and they're going to highlight them here. We have a lot of intern projects. This is only a small selection. So if you're interested in other research projects at Red Hat or collaborative projects with BU and Red Hat, please do get in touch with us, and we're happy to share a lot more information about other intern projects if you'd like to know. But today, I'd like to highlight 4 speakers. Rajath Vanakudare, who's going to tell us about Curator, which is a project for usage reporting in clusters. Isaiah Stapleton, who's going to give us an update on Unikernel Linux. And those of you who've been coming to RIG meetings for a while will recognize Unikernel Linux as something that we have several students working on. And this is the first undergraduate project for Unikernel Linux. Joel Slobodnik, who will talk about Fedora Raspberry Pi drivers and other things having to do with kernel programming and how to make Fedora more useful. And finally, Abirami Delan, who will speak about open source education. So with that, I'd like to introduce Rajath, who's going to kick this off. And I hope you enjoy the RIG sessions. And each speaker, if you don't mind, just say when you're done, and the next student can come right on directly.
Great. Thanks, Heidi, for the introduction. Let me share my screen. Are you all able to see my screen?
Yes.
Okay, great. So hello, everyone. This is Rajath here. Today, I would like to take this opportunity to talk about Curator operator and also go through what I've been doing throughout my internship in the last 12 weeks. So yeah, so what we'll be discussing today, we'll go through the introduction of Curator operator. I'll even tell you what's an operator if you're new to this. And we'll dive deep into the project on what's the purpose, why we need this operator, the working, the results, and what's the future. I'll also drop some links at the end, which will be really helpful for you if you ever want to look at this project. So about me, I'm a grad student at Northeastern University, and my master's is in computer science. I'm originally from Bangalore, India, and my hobbies are I like going on hikes. I play my hand in different sports, and also I love traveling. I've also been working as a software development engineer for 2 years, after which I came for my master's. And it's really good to be back as an intern again. So let's dive into the technical stuff. So what's an operator? So an operator is something which controls the state of another application. So you can see the diagram here, which shows like the 3 different stages of an operator. One is it observes, checks the difference, and acts upon it. So in simple terms, this is exactly what the operator does. For example, we want an application probably to be scaled to 20 different 20 pods in the morning at 8 a.m. So a user or the administrator does not have to come and click a button. Instead, if there's some logic written, every time there's a requirement, the operator basically checks for the environment, see that the expected state is the current state is not meeting the expected state. That's the difference part, and it acts upon the current state to make it reach the expected state. So this cycle keeps continuing, and this really helps a lot in operations and scalability purposes. So our Curator operator is also something similar, but it's just that we run it periodically using some cron jobs. So this Curator the operator makes the Kubernetes really awesome because it gives the ability for the Kubernetes and the OpenShift to add more components to it and automate everything. Let's have a look at the Curator operator. So I would like to stress on this point that it's an air-gapped infrastructure consumption analysis tool. You might have heard heard about different infrastructure consumption tools, but Curator specifically computes all the data in-house, and it does not let any metadata go out of the cluster. So it basically computes different metrics like CPU usage, memory usage, volume usage, and for each different namespaces, it generates reports periodically, like maybe daily, monthly, and weekly reports. Currently, it's an operate first project, and below the few features that highlight the operator. One is the periodic reports. As I mentioned, you can generate daily, monthly, and weekly reports, or you can query the API which is there and get the reports for whatever duration that's required for any number of parameters. We also have a backup option, which uploads all the data to the S3 bucket so that there's no loss of data. Because we know that the containers are volatile, and if the cluster goes down, there is a possibility that the data is lost. There's also in-cluster data. If the user chooses not to use anything else and he just wants to look at the data, he or she can go ahead and have a look at the data in the cluster. There's also an option for automated email reports. So every time the report is generated, based on the frequency, the automated email reports are sent to the users listed in the mail list. So these are the few features. So let's go to the purpose of why this operator is important. So I've put it in perspective of 4 different users. One is the cloud administrator. So it is very important for the cloud administrator to know the infrastructure resource utilization across the cloud, because they are the ones who maintain the cloud and all the infrastructure details of the cloud. So it's important to see which project is using how much of data, and it helps them plan accordingly. For research leads, this can be an important parameter in any research study that's been happening. So this lets you understand what is the resource used by the particular project. Again, this can be used in various purposes. It can be a parameter in your research, or can help in computing the cost required for that particular project. In terms of end users, we know that every end user has a limit on the quota. So it helps in planning ahead to understand what are the limitations that I have, and how to so that I don't hit a roadblock in my execution. In terms of analysts can look at this data, check for the trends and do the resource planning. For example, they probably want to give more allocation for a particular project, and by analyzing the current trends and how many users are there, and if there are more users need to be added to that particular project, they can take a decision on expanding the cluster, or allocating more data to the project. So the main purpose here is that we don't send data anywhere outside the cluster. So whatever is existing is currently housed in the OpenShift cluster. So there is no metadata transfer. Why Curator over the other options? Well, there are a few other options which give you the infrastructure utilization data, but there are a few additional points that the Curator provides, such as it's an air-gapped operator, so it serves the true purpose of having a private cloud. Easy to access and understand the reports. So the reports, as we mentioned, there's an email service which periodically sends the reports to the users. So there is no need for someone to go and have a look at that particular report on a regular basis. Instead, the reports are delivered to you automatically. It focuses on the resource consumption for each project, and it also focuses on the history of the time period that's given. For example, the last month of data, and for example, if you want to check Cocometrics data, that the data that is in Cocometrics is really very vast and vague, in the sense that you will have to manually compute all the data to get a particular infrastructure utilization. But Curator does all that for you and gives you a polished report. There's automated delivery of reports, and option to back up these reports so that you don't lose in case if the cluster goes down. This data could also be used in the infrastructure billing system. If you have some logic implemented where you know how to bill according to the usage, this data could be used to feed into that too. Let's go to the working of the operator. So the Curator uses the Cocometrics operator data to compute the metrics. So we already have a Cocometrics operator, which is an open source operator, and it queries the data from the Prometheus. So you can see the small diagram here. So this is the Prometheus, this is the Cocometrics, and this is the Curator operator. So Prometheus has like all raw data, and Cocometrics basically constructs few PromQL queries. So the PromQL queries are really complex, and that is fetched by the Cocometrics from the Prometheus. So we don't have to re-engineer this part. So instead of that, what we did was to use the Cocometrics data and fetch it and compute the readable reports. We also, the operator has multiple cron jobs. One is the fetch data periodically. So Cocometrics update the data every 6 hours, and Curator also runs the fetch data every 6 hours, which is again configurable, and it fetches the data accordingly. There's option. It generates reports periodically and also sends the emails periodically, which is an optional parameter. As I said, there's an option for us to update this to the S3 bucket. So we have different tasks which, when spawned, we can upload that data to the S3 bucket. Another option is to query using the APIs, assuming that I want the data from the last 2 weeks, and it's just not the weeks or 1 day's parameter. And just making an API call would instantly give us all the results. In terms of storing the data, we use the PostgreSQL DB, which stores the formatted data. It has different log tables, and also the report parameter table, which has the actual reports that is generated. Again, I spoke about the API service, which would give us the reports instantly. This is an architecture diagram of how the whole deployment or the operator would look like when we put it on an OpenShift cluster. Assuming that there are multiple projects, we have some PVCs and persistent volumes. We have a PostgreSQL DB, which stores all the required data for us. And there's a PSQL service. So in the Cocometrics operator's namespace, there will be a Cocometrics pod which is running. And the fetch data would talk to this Cocometrics pod, get the data, talk to the PSQL service, and feed the data into the DB. And then we have like multiple cron jobs with this report generator and email cron job. There's also an API service which talks to the DB to get the data that is required by the user. So the report generator cron job does the task of filling the reports human table. So that data is computed. There's a logic in between which takes in the logs data, which was fetched from the Cocometrics, computes all the data that is required and puts it into the SQL DB. Email service talks to the DB again, fetches the required details like based on the frequency, and sends email to the users that are listed in the mailing list. Let's talk about the results. So you can see that this image here, this is really hard for someone to understand on what this data is, right? So this is actually the data from the Cocometrics that we get. So without using Curator, this is what an administrator would probably be reading. So it gets really hard for us to understand what this means. So putting it in a format which is readable and understandable by all the users is really important. Hence, computing, we have some logic which computes all this data according to the namespaces, puts it in this particular format. Here I put a short screenshot, and there's also a link which will lead to the reports that was recently generated. There's just 2 columns, which is the CPU core total and request, and it is generated according to the project or the namespaces. So for the results, it's very important for us to do some sanity tests, because whatever data we have is it's a report that's generated. So we'll to verify those reports, we ran some sanity tests with the Prometheus data. So we constructed some complex Prometheus queries, which will run on the PromQL query tabs, and we compared that results with our Curator data. So we observed that there's like less than 5% variance. Most of the data we see is almost the same, but there are few cases where there's like less than 5% variance. And the sanity test was run on all the namespaces to verify the accuracy. We also listed a document at the end which lists all the PromQL queries that we've used, and also a document to which sanity test reports are there. So with the data that we had, I have generated a graph. So this graph explains 2 things. One is the pod CPU request, that's the Curator report that we got, and the pod CPU request, the Prometheus report. So Prometheus is the one that we compared it with. So you can see that the variance is like very slight for most of the projects, but for some projects like Cocometrics operator and we find like less than 5% of variance. Again, here for memory, we see that the variance is like really very less. So that assures that the operator is getting the results in the right way. Similarly, for volume storage, I generated another graph which shows the variance for both. Great. So the red basically shows the Prometheus reports. Coming to the report parameters, so we can focus on three type of parameters here. One is the request, usage, and limit. For three different parameters, those are the CPU usage, the memory usage, and the volume usage. So every project has these three important parameters which define the resources that are used by the project. And there is a frequency, there is namespace, and these are different parameters that we fetch from the reports. So request is basically what the pod particularly requested for, like for example, 500 MB of data for soft storage, but the usage could be less than that, because every time the pod might not use the 500 MB of requested storage, and usage varies, and that's what is being computed, and all that data is listed in our reports. And limit is something that's set by the every namespace. So if there are multiple pods, they total combined cannot exceed that particular limit. So in a single report, a user or an administrator can understand all the details about the complete project that's being used, or the namespace that's being used, and what are the different resources consumed by that particular namespace and the project. So there are different tasks which got completed in my 12 weeks of internship, which I would like to highlight. Yep.
Sorry. So we have 4 presentations we have to get through.
Oh, okay.
I just want to let you know. So if you could wrap it up, that would be good.
Yep.
People can look at the rest of the slides if they're interested with the links that Jen will post on the page.
Okay, got it. Yeah, sure. Yeah. These are all the tasks completed. And a few things talk about the future. We can have persistent storage, analytics tool, customized report, and automated test bed. These are a few things that could be implemented. I also have some resources and links listed here, like the Curator operator repository, analysis doc, Curator overview, and read the docs is really important, but it's work in progress. So it's like one stop for all the resources that you want. Firstly, I'd like to thank Surbhi, Gagan, Ajinky, and Heidi for all the support and mentorship, and all my fellow interns. They've been amazing. Whenever I come to office, I've been interacting with them. So yeah, thanks a lot. If you have any questions, then you could just email me. You can connect with me on LinkedIn. I'm happy to answer any questions.
Thank you. So in view of the time, if anybody has questions, please connect to Rajath directly or contact me and we'll get you in touch.
Thank you, and sorry for going over time.
That's okay. Okay, so Isaiah, you're next.
Can you guys see my screen?
Yes.
Okay, cool. All right, so hello everybody, my name is Isaiah Stapleton. I'm a software engineer intern on the research team, and today I'm going to be talking about the work I did this summer as a part of my internship on the Unikernel Linux project. So what are we going to be talking about today? First, I'm going to give a brief introduction about who I am, some necessary background information for actually understanding what the Unikernel Linux project is. Then I'm going to actually talk about the Unikernel Linux project itself, my main task I was tasked with for this project, why this work matters, my current progress with this task, and then after which I will talk about a side task I was given, which is related to my main task, however it differs slightly. Then I will talk about some problems and solutions I ran into with my main and my side task. Then I will talk about some next steps, and at that point, should conclude the presentation, we can go into the Q&A. So brief introduction about me. Like I said, my name is Isaiah Stapleton. I was born in Dover, New Hampshire. I moved to Charleston, South Carolina around 12 years ago. I'm currently going into my senior year at the College of Charleston, majoring in computer science and minoring in data science. So to understand what the Unikernel Linux project is, it's important to understand what a unikernel actually is. So what is a unikernel? A unikernel is essentially a highly specialized operating system designed to run a single privilege application that's linked with a kernel and executes in a single address space. It only contains application code as well as all necessary operating system functions required by the application. So in short, it is essentially just a highly specialized operating system designed to run one single application. The benefits of this are very fast boot times, increased performance, as well as increased security. Sometimes when I tell people what a unikernel is, they get confused at what the difference between a unikernel and a container is. And I think it helps to look at the difference in the architecture between the two. So if you take a look at the architecture of a unikernel, you can see that each unikernel has its own kernel with the library and the application code built directly in, whereas a container has a shared kernel with the library and the application code being separate. So what actually is the Unikernel Linux project? The Unikernel Linux project is essentially a small patch to Linux and glibc, which allows one to build many programs as unikernels. It's not actually aiming to turn the Linux kernel into a unikernel, but rather offer a system for applying unikernel optimization techniques to the Linux kernel. The current goals of this project are to offer a selection of applications optimized using these unikernel techniques, and then working towards the upstream submission of the UKL patch set. So what was I actually tasked with for this project? Well, my main task for this project was to port Nginx over to the Unikernel Linux project and perform benchmark testing in order to compare the results to the lupine benchmark test. All you need to know about Nginx is that it is a very popular open source web server, and lupine is a highly specialized operating system that employs similar unikernel optimization techniques as the Unikernel Linux project. We're comparing against lupine because they're one of the most recent specialized operating systems that employ these techniques, and their performance is better than other state-of-the-art techniques at the moment. So why does this work actually matter? Why is it important to port Nginx over to the Unikernel Linux project? Well, in order to get our changes to the Linux kernel pushed upstream, we have to show that these changes to these applications can make a significant difference in their performance. So by porting Nginx over to the Unikernel Linux project and performing benchmark testing on it, it pushes us one step closer to that goal of pushing these changes upstream to the Linux community. So where am I at with the current progress on this task? Well, first I had to build Nginx from source, after which I had to figure out which dependencies it has and their dependencies all the way back to glibc, and then make sure we can actually build Nginx in a UKL compatible way. After which I had to actually build Nginx in a UKL compatible way and then get it to boot as a UKL kernel. And then the most recent task that I completed was to perform benchmark tests on Unikernel Linux Nginx. Here you can see the preliminary results for the benchmark test. Now this is just one single benchmark test. On the left-hand side you can see one benchmark test for UKL Nginx. On the right-hand side you can see one benchmark test for lupine Nginx. You can see that there is a performance increase for UKL Nginx over lupine Nginx, a very great performance increase. There's actually a 39% increase in requests per second, 28% decrease in time per request, and a 39% increase in the transfer rate. Now these must be taken with a grain of salt because lupine Nginx was run on their own hardware, whereas UKL Nginx benchmark tests were run on my hardware, my laptop. And so we are trying to currently get the lupine Nginx benchmark tests running on our hardware to give a more accurate comparison of the performance increases for UKL Nginx. We've had some issues getting lupine Nginx to run on our hardware, and we actually have an individual separate from me who is working towards getting it run on the same hardware. However, until that is done, I cannot provide a more accurate benchmark test to compare. So I'm offering these preliminary results for the benchmark test. So in the meantime, I was given a side task for this project. And this side task I was given was to implement TCP shortcuts in order to increase the performance of Nginx. Essentially, there's a TCP code path for send and receive in the Linux kernel. The first few functions in this code basically check conditions and flags to find which condition or which functions to call for send and receive because there are different options available. However, since we already know which path it must take, we're able to bypass all of those checks and go directly to the necessary function. This gives us a performance boost because the code now does not have to waste time making a decision for what path to take every single time we send and receive. So I was able to implement the send shortcut successfully. However, I have not yet been able to implement the receive shortcut. I've run into an issue in the process of trying to implement the receive shortcut that we'll actually talk about in a minute here. So I'm going to talk about now some problems and solutions, some of the bigger problems and solutions I ran into for both my main task and my side task. So this was one of the bigger issues where we were getting, after I got Nginx to actually build as a Unikernel Linux, in a Unikernel Linux compatible way, when trying to boot it, I was getting this open dev null fail, no such file or directory. This is required for Nginx to boot. And the cause of this was that the dev directory was not populating when building UKL Nginx. Essentially, when a UKL application boots, an init script runs and it creates the dev directory, but it's empty because Superman builds the root system out of RPM contents, which don't include the dev directory. On a real system, the dev directory is populated by systemd dev. However, in the UKL build, we do not have systemd dev, so the dev directory doesn't populate. This is a bigger problem that Richard Jones actually had to handle. He had to add changes to the way Unikernel Linux applications are actually built in order for the dev directory to correctly populate. Once this solution was implemented, this problem was solved, I was actually able to get Nginx to boot. However, now Nginx is booting and it's not performing in the way that we thought it would. It's not performing correctly. And when looking in the error logs for Nginx, there was this socket pair failed while spawning a worker process. The root cause of this was essentially a function in the Linux kernel called putUser that writes values from the kernel space into user space. If the destination was found to be outside of the user space, the process fails. And so we're working with unikernels. We are only in kernel space. We're not working in user space. So we were trying to write from kernel space to kernel space, and it was checking those bounds of the address space and seeing that it was in kernel space, not user space, and so the process was failing. The solution to this was we had to modify the Linux kernel to bypass this check to see if it was in the user space. After this solution was implemented, this problem was solved, and Nginx was able to run correctly. And so now Nginx is running correctly, but now I'm on my side task. And my first problem I ran into on my side task was an undefined reference to the shortcut function that we implemented. So it was an undefined reference to the shortcut TCP send message. The cause of this was Nginx failing to build, causing the entire build process to halt. Essentially, when I implemented these changes into Nginx, I had to write into the code, I had to tell Nginx that this shortcut function is somewhere else in the build, somewhere else in the code that that Nginx will not be able to see until the building and the linking process is complete. However, Nginx was not correctly seeing that function, and it was just failing to build, and it's causing the entire build process to halt. The solution to this was editing the Nginx makefile to ignore the failure to build Nginx in order to continue the build process. The reason that this solution works is because now it's ignoring Nginx failing to build. It's getting to the end of the build process. Everything is linked correctly, and then Nginx can correctly see that this is where the shortcut function is, and now it can properly see it, and it's working correctly. So after this solution was implemented and this problem was solved, I was able to actually get the shortcut TCP send function working correctly. However, when trying to implement the receive shortcut, I receive a kernel panic during benchmark testing. It seemed to be random. It would work for a while, and then there would be a random kernel panic. We do not know the root cause yet. This is a very recent problem we ran into. We're unsure of the root cause because the way we implemented it should be working. It seems to be a problem with the UKL build itself, not Nginx or the TCP shortcut. However, that's something that we are going to have to look further into at the moment. And so we do not know the cause, and we do not have a solution for that yet. So what are my next steps? Well, we still have to get the Lupine benchmark test running on the same hardware so that we can compare the UKL Nginx benchmark test to the Lupine Nginx benchmark test. That way we can more accurately tell the performance increase for UKL Nginx over Lupine Nginx. After this, I will work to further optimize UKL Nginx. That about concludes my presentation. I'd like to give special thanks to my technical mentors, Eric Munson and Larry Woodman, my early talent mentor, Shamir Fison, my manager, Heidi Dempsey. Special thanks to Ali Raza, Richard Jones, and the rest of the UKL and the research team. And now, if anybody has any questions, feel free to ask me. Feel free to email me or connect me on LinkedIn and ask me there.
Yeah, there's a couple of questions from Ari in the chat, Isaiah.
Let's see.
Or Ari, you can just speak up.
Sure, I'll just ask one of them. I was just curious if you, by the way, nice work. I was curious, what are the security implications of bypassing the put user test?
So that's actually something that was kind of a hack. Like it's not something that we want to leave in. So that's something that we're going to have to fix. That can be an issue. And especially it can be an issue because the non-UKL processes that are running still need this put function to be working correctly. However, we edited it to only work for just UKL processes, if that makes any sense. Essentially, it's just a hack that we put together in order to get this working in this case. However, we do need to go back and fix that.
Okay, got it. You just wanted to make it work and see if
yeah, exactly.
Makes sense.
Okay, thank you, Isaiah. You can also follow up on some more in chat. Next speaker is Joel. And we see your slides. You have to unmute yourself, though.
All right, that's a virtual classic. Okay, let me go present then. Okay, and it's recording, correct? Hello? Okay. So, hello everyone, my name is Joel, and I'm going to be talking about Fedora Raspberry Pi drivers. I'm on the kernel development team, and I've been interning this summer. So this is the agenda for today. I'm just going to briefly introduce myself. I'm going to give an introduction, just talking about some background information so that we're all on the same page. And then I'm going to go into I guess the main project that I've been working on this summer. I'm going to be talking about why it's important, and yeah, let's get into it. So again, as I said, my name is Joel. I just graduated this May with a bachelor's in computer science at the University of Massachusetts Lowell. And the way that I heard about this internship was through this class that I took in my final semester. It was an intro to Linux kernel development course, and it was actually run by some engineers at Red Hat. And I see Joel Savitz, who's in this call right now. He's one of the people who was helping. Yeah, that's Joel. He was one of the people who was helping with the course and giving some great lectures. And I'd say just a very good intro to what kernel development is about. So I'm going to give some background info again, so we're all on the same page here. So if you haven't done much kernel development in your life, this is some important information to know. So bulk of kernel development, I'd say, is in coding device drivers. And what is a device driver? Well, a device driver is pretty much the software that allows devices to plug into a computer, for example, and actually function. Like you kind of think about printers or keyboards or mice, all of them require device drivers in order to function at all when you plug them into the computer. And this is just a kind of a side note, but usually they're not built directly into the kernel. They're usually implemented as modules that actually build the entire kernel. You can quickly load them in after building them separately. And then the other piece of information that I wanted to talk about before going into the meat of my presentation is on the Raspberry Pi. So I'm sure a lot of you have heard of this before. It's just a portable computer, except what's neat about it is that you can connect a wide variety of peripheral devices to it. So some examples are cameras, audio devices. Obviously, you can plug in a USB keyboard And the last note that I just want you to keep in mind is that it has a video core GPU. So this is another peripheral device that you're able to connect to the Sense Hat. This isn't exactly what I've been working on, but I just wanted to mention it because this was kind of one of the beginning efforts of, I guess, a small group at Red Hat trying to make Fedora more compatible with the Raspberry Pi. So this is a Sense Hat that or a device called a Sense Hat that a previous intern was working on, and is able to sense different things in the environment. It has an LED grid, and so I just want to say that this thing is very close to being merged upstream. I was able to help with the final patch, kind of getting that ready, and it really just needs to be tested. So I only add that in there to note that there is progress happening, and the efforts of the people who are trying to improve compatibility with the Raspberry Pi and Fedora, there's definitely fruits from their labor, and I think it's just very exciting. So I wanted to mention that. So this is the project that I've been working on for the summer. It's called VCHIC for short, but it stands for Video Core Host Interface Driver. And I mentioned before that kernel drivers are usually pieces of software that enable devices to work when plugged in. But like, although this is a necessary thing for certain devices to work, it's not, I guess, directly interacting with the hardware that you plug in. Instead, it's more of an interface for device drivers to talk to in between the kernel and the device driver. So more specifically, the VCHIC provides an interface for the hosts, which is the devices, to communicate with the video core GPU firmware. So some of the devices that are required or that require the VCHIC driver are camera devices, audio devices, and you're also able to implement various abstraction layers on top of VCHIC. You can see it from the diagram on the right that the camera doesn't go towards VCHIC directly to talk to the GPU, but it goes through the MMAL or multimedia abstraction layer. So I've been doing a lot of work on the VCHIC driver, not necessarily in changing the code directly, although I've done some small changes here and there. There's like a to-do list that's public, and it has a list of different things that need to be completed. But the main thing that I've been doing this summer is creating documentation for the driver. You can kind of see the GitHub. There's not a whole lot of participants who are making changes to this driver. It's quite limited. And a big reason of this is because the code base is so vast. It's thousands of lines of code, all in C. And with kernel development already being like not exactly the most mainstream style of programming, it becomes very hard for new people to contribute to this driver. And so I've been making documentation so that the range of people that are able to work on this and contribute their ideas can be more vast. But this was just like a small diagram of the initialization process and how the driver gets started. So this is some pretty standard device driver initialization. The platform drivers initialize, and then after that, it triggers 3 threads to be initialized, which does the bulk of the protocol. So why should we care about this project or any of this? So probably the biggest reason that this is of interest to Red Hat is that you probably heard of Rivos, which is the Red Hat in-vehicle operating system. It's kind of one of the hot projects right now that people are working on. So pretty much the Raspberry Pi is going to be used as a testing platform for Rivos. I want to clarify that cars aren't going to be running on Raspberry Pis. That'd be pretty crazy. But it's good for testing because the board using the Raspberry Pi is similar to what's actually going to be in the car. And so what Vnginx is going to allow us to do is it's going to help us to be able to test out cameras, for example, which are definitely going to be used in cars. So that's why Red Hat cares. Unfortunately, there's a problem in the sense that in order for us to use RHEL or Rivos or even Fedora on the Raspberry Pi with Vnginx, the driver needs to go into the upstream kernel. So far, the bulk of the development on Vnginx has been on the downstream kernel or on the Raspberry Pi operating system. And so there's a huge list of to-do items that need to be done in order for us to be able to merge it upstream. And since Fedora, RHEL, and other operating systems that are based on Linux depend on the mainstream kernel, we really can't use this for testing until it's merged. So with that being said, I gave a little brief overview of this project, and I've talked about why it's important and also just the implications of what we can do if we get it working and upstream. So I just want to talk about how you can get involved. So the effort of making the Raspberry Pi more compatible with Fedora has been in the works for a little bit of time, but there's a GitHub repository that will describe how to run Fedora on the Raspberry Pi. And I'm not going to go through all of the instructions because I think we're a little tight on time, but you can go back and refer to the slide deck afterwards. Something that I do in order to work on Vnginx is I first clone Linus Torvalds' tree of Linux, and then I set Greg K.H's tree as a remote. And this is because all the changes that are going to be merged upstream eventually are first in Greg K.H's tree. So in order to get the most up-to-date code on Vnginx, we need to pull these changes from this remote. So I'll say the last thing that would probably be good. You can't do it right now, but hopefully within the next week you'll be able to do this. You can read the documentation, which is what I've been working on. And pretty much my hope with that is you'll be able to understand this driver as well as I do after these months. But you'll be able to do it in like a week or two. That's my hope. So also, this is another useful thing that I discovered while working on this driver. Usually, in order to test out the changes, right, you need to build the kernel after you have done the to-do list item, so just to test out that it works. But if you run it on the Raspberry Pi directly, it'll take like 8 hours or so. So you'd like have to run it before you go to sleep, and then maybe wake up and there's like an error there, and then you need to run it for another 8 hours and just keep the process going. What I found to be useful is cross-compilation, where you build the mainline kernel on a more robust device, such as our work laptops, and it actually ends up taking 15 minutes instead. So I included this in there because if I didn't, I think that'd be kind of evil. So with that, I want to thank all of you for your time, for listening. I want to thank my manager, Heidi, my mentor, Joel, and yeah, everyone who has been coming into the office. It's been great getting to know all of you. So thank you very much.
Any questions for Joel? And by the way, thank you for saving all that time of future interns who work on the kernel. Okay, seeing no questions, let's move on then to Abhirami, our last speaker. And your slides are there, but you're muted, Abhirami.
Yeah, am I audible?
Yeah, we can hear you.
Oh, thank you. Okay, good afternoon, everyone. I appreciate your time today. I'm Abhirami Dayalan, a master's student at the University of Texas at Dallas. This summer, I'm part of this project called Open Source Education. Open source education is actually an initiative towards making education open source and to achieve a unique educational experience powered by the open cloud services. We believe that the notion of openness in building a software application can be applied in the educational domain by exploiting and integrating the technologies like the Jupyter book, which is a good tool for authoring online books, to deliver the textbook content, the idea of containerizing the application source code, and a cloud-based Kubernetes platform like OpenShift to manage and deploy these applications, the containerized application on demand to students. This project encompasses supports to the live lecture materials, a dedicated lab environment for the students to explore and learn, and also a way for the professors to continue authoring their teaching materials and notes. This project has two perspectives. One is the infrastructure, which is to provide the required infra support for the textbook content. That is to build this S2I builder image for the Jupyter notebooks, which gets deployed in the OpenShift environment. The second part is this creating the rich presentation materials, the actual textbook contents. Source to image is actually a framework that makes it easy for the developers to create an image that we call the builder image, which actually takes the external application source code as an input, and it creates a new image which runs our assembled application as an output. The project thought that Red Hat provides the recommendation on the Python software stacks, runtime environments, and the deployment configuration. The ThoughtStation repository provides the instructions on building the S2I builder image for these minimal Jupyter notebook images. And we are actually leveraging this repository in our project. So these are the important layers of our proposed stack of open services that can be integrated to achieve our goal. So the bottommost layer is obviously to provide the hardware support, which could be a open public data center. We will need a collection of tools and technologies to deliver the textbook content like Jupyter book and Git to version control the material as the professor continue to update them. And we will have an open cloud environment like OpenShift to act as a bridging network between these. This form as the major backbone of this idea that if we could make it as a generic template kind, it can support the actual textbook material which sits on the topmost layer. So our idea is to create a generic platform or a template for this S2I builder image for the Jupyter notebooks that can support these rich presentation materials, the notes that the professor could create. So if we could achieve this, then this can be applied on similar courses that the professor will only have to create the coding, the content for the teaching material and need not worry much about the builder images. So with this proposed...
Rai, can I interrupt you just for a second? I'm sorry. Somebody in Rocketry is sharing their live screen right now instead of Abrami's slides. So if you could please stop that.
Okay.
We removed them, but they came back. So Abrami, if you could share your slides again, please.
Sure, yeah. Sorry, I was not aware.
No, it's not your fault. They just stole the screen. I'll go up there and get them if it happens again.
So I'll just continue with this.
Mm-hmm.
Yeah. So yeah, so with this proposed platform or template, we can achieve the pinnacle of success where, say, every student in a class of, say, hundreds will get to access the same broad educational materials all through just a web browser. And we believe this will enable teaching the computer science courses in a real cloud-based environment. And it is also a great step in changing the process of the learning and the teaching experience as well. Like I mentioned earlier, it is highly applicable with our S2I Jupyter Notebook images being available open. This can be easily applied for other courses and can be utilized. I have shared our repo details here. Okay, so our immediate goal is to have a working image in the Red Hat Operate First environment. We currently have a Ubuntu-based one which supports the subject under the covers, the OS about the operating systems, and we are targeting to build a Fedora-based S2I builder image based upon the universal base image of Red Hat. And yeah, that should support the textbook material. And the end goal for a project is to deploy this in the NERC cloud that we can use it in the upcoming semester. So yes. This is a template that I mentioned earlier, which has all the library support and the extension that is required to support the textbook content, which is this. So this textbook is prepared based on a Jupyter book image. So when deployed, this gets ingested into this Jupyter lab, and you see this deployed in an OpenShift environment. We are working on developing this in a Fedora-based one. And since it is a universal base image, not every package were available. The default system libraries were available in it, and we are working on building them from source. And we are into this issue of transitive dependencies and ways of handling them through, again, building them again. So yeah, we are working on completing that and making it available soon. I have also added the talk from the Professor Jonathan of Boston University here, if anyone is interested to learn more about this initiative. Yeah, and thanks to my mentor Heidi and Professor Jonathan from the Boston University for their support. I'm open to any comments or questions, if any.
You're getting accolades from the from the chat.
Thank you.
And Professor Ari, are you going to start teaching using Jupyter Notebooks now?
Not yet, but it's a very interesting idea.
I just giving Ari a hard time since he's asked questions about everything else. Okay, well, I thank all of our interns for these really interesting topics, and you all did a really good job on condensing down an entire summer's worth of work into 15 minutes, including questions. I really appreciate you being here and collaborating with us, and hope to see you again in the future. The next RIG meeting is not going to be at the usual time. It's going to be postponed because of Labor Day. I'm sure no one really wants to be coming to the RIG on Labor Day or right afterwards. So we will see you all on September 20th, and we'll be sending out revised invites for that. Thanks for joining, and the links to the slides and the video will be available on research.redhat.com event page for this RIG meeting later on if you want to follow up on anything you saw. Thanks for joining.